Good afternoon, everyone. As Jamie said, I'm going to talk to you about model build workflows. So our model build workflow is, our aims are twofold. So kind of as actually Darren presented in his keynote speech, model build is kind of this, it's not sexy, but it's an essential part of getting to the bit that you want to impact your design with, getting to your analysis, getting to your optimization, your design exploration, and updating your designs. But to do that, you've got to build the model. And so what we're trying to do is get that lead time reduction in building your squares and triangles. And we're going to do that with all of the features that all of the guys have been showing you today, of the 2D meshing, geometry cleanup, 3D meshing, all of that we try and wrap in the model build workflow, but we add on top like this layer of model management. And it's built on top of this model build process, which is built on parts, subsystems, and connectors. My colleague Tim will cover connectors afterwards. I'm going to take you through parts, including in the live demo. Subsystems we're not going to demo, but they are an extension of parts. So if you understand the concepts of parts, you can easily move up in working on subsystems as well. Our process is designed to take you from CAD all the way to your simulation level models, and we build off of revision management, representation management, and instances, and all of which I'm going to go through today. So kind of as mentioned, we start from CAD, we build one particular subsystem using Part Browser. We take that each subsystem, so in this vehicle example, got a body in white. You take the body in white, but you might also build a door subsystem. You might build the load cases. You might have a barrier, rear barrier, side pole. You might have suspension subsystems. So you build in isolation each of these subsystems using Part Browser. You assemble them all together with Subsystem Browser at the end. So it's really this process of growth from single subsystem to multiple subsystems. So I'm just going to take you through today, starting from CAD, using Part Browser to get you to one subsystem, but the process is the same. You would build this one subsystem, but then you would build multiple subsystems and then assemble them together using connectors. So a lot of our technology is built off of our libraries, and these really facilitate collaboration. So what our libraries enable us to do is to work in an environment where we have different users, but they're all pushing and pulling data into a common database, which is our shared library. This library sits on a network drive on a shared area that everyone has access to, so that when somebody wants to pull out some part that's been meshed before, they can just connect to the library and pull that mesh out. So this enables model reuse. So you've got the second model after the first one, how many parts have been reused? Well, you've meshed it before, so let's just reuse the mesh. It also, as I've kind of alluded to, facilitates collaboration because we can divide a single model up between our team. I pass off to one team the upper body, another team the glazing, and another team the underbody, team or team member. They mesh their parts, save them into the library. I can then, as one member, go into the library, pull all of these parts that have been meshed and assemble them together. So it's this common data storage, and so we're not passing around solver decks or HM files in an uncontrolled manner. Everything's managed within this library environment, so it tracks who's saved the parts into the library, what they've saved into it. You can add comments about the design changes, and all of it's revision controlled. A lot of these slides, or my slides so far, have been automotive focused. So just to mention, here's exactly the same slide with some aero images. We have a couple of versions of the slide deck, but seeing as we're in the British Motor Museum, I thought I'd use the auto ones. But just to say, this workflow is kind of independent of vertical. It's also independent of solver. So whether you're working in Optistruct, Radios, Dyna, Abacus, it's the same workflow. So in my demo, I'm going to take us through, starting from a CAD import. We're going to see how Part Browser has the traceability to see where the CAD has come from. We're going to see how we can use Match, which is our AI that Dan Back mentioned in his introduction, to try and find similar parts to reduce modeling so that we're only meshing parts that are repeated once. We're going to use instancing. So once we've found those parts that are the same, and we only mesh them once. As we make a change to one of those instances, I can propagate that out to all of the other instances that are in the model. We're going to look at batch mesher integration. So as mentioned and as shown in the presentation on 2D meshing, we have batch mesher, which gives us our best practice meshing with the washers and the nice mesh flow, but we have in part browser integration to run that in parallel. And as we've looked at and kind of showed on that slide, the collaboration, and I can showcase some of that. So let me swap over here into a live session. So I've got this model imported, and the first thing to say is that once you import a model, you may have noticed in recent versions you get parts imported. So I noticed that the very first question that Bao was up here asked how many years of experience people have had, and there was lots of people with 10, 15 years of experience. You'll be very familiar with working with assemblies, with components, and you might have seen parts start appearing in your model after importing geometry and wondering what they are and how to use them. So parts are a layer above components. They eventually will replace components, but a part you can consider analogous to a component in many cases. So we take one of these kind of sheet metal parts. It's a single thickness, so you may model that as a component with a property of a single thickness. So for us, that would be one part as well. So one part, one component. The same applies if you were to solid mesh something. So if you solid mesh something, you'd have one component with one p-solid property if you're an OptiStruct, but you'd have a solid property card. And that's, again, one component, one property. For us, again, one part. The difference between components and parts is where you have, so in this case, say one of these castings or the extrusions, when you have a casting, but you would model that, if you model that as a shell mesh, you may then have different property regions for different thicknesses. So you may have 5 components with 5 different property patches with 5 different thicknesses. And you may kind of try and group them all together with some naming convention on the components. So it might be casting underscore 1 mil thick, casting underscore 1.5 mil thick, so you group them together. For us, that's not 5 parts, that's one part. It's one part because it's one CAD object. We maintain our traceability back to the CAD object, and it enables us, rather than trying to grab 5 components, if I want to replace that casting with something else, I can just do that by replacing one part. So that's the key difference between parts and components. The other key difference is that as you start using parts, there's a lot more functionality built off of parts that components aren't supporting. And I'd like to go through some of those today. So as mentioned, you import your CAD and you get a part structure, okay? So the thing to note here is this CAD structure matches the CAD structure coming from PDM system or just simply from a regular CAD export. So this, as I talked about, kind of it's one part for one CAD object. You can see, hopefully, that there's this revision column as well. So all of the revisions get populated with the history of CAD, and we maintain this all the way through into the solver deck, so that once you run your model, if you go back and you look at that solver deck and you say, okay, well, what was this model built from? You can kind of get that traceability to see back where the CAD version was. So if you want to do some different studies, you say, okay, well, this part has been up revisioned. I need to go back into my model and I need to check, did we use the latest version? The revision tells you what you used. We also have this representation column, and I'm going to show you some of the different representations, but as you import the model out of the gate, everything is the CAD representation. We also read any metadata that's available. This may include IDs, material information like material name or material ID, and we use them during the batch mesh process to create properties, materials with the right names, IDs, and even on the property creation, we extract the thickness from the geometry as part of our batch meshing process. So there should be no creation of properties or materials anymore. We do that for you, and we automatically create them with the right names and IDs and thicknesses. So the first thing I would like to do, now we've got the CAD imported, we kind of looked at the hierarchy, is one of our tools that's supported only on parts is the match tool. And this is an an AI tool where we very simply pick all of the parts. We choose a similarity percentage, in this case 95%, and we hit and we run match. And what it'll do is it checks each part, defines the shape of each part, works out which parts are similar to each other, and then it will say these parts are the same shape. I will link them as instances. And so if we review these parts here, so these rails, it says, are instances of each other, so left and right-handed. So you may get instances for free, and they come in imported if the CAD has been created that way. We also take reflected parts, which we can, because we're doing finite element analysis, and we can make some assumptions and simplifications. In the real world, these are not the same manufactured object because they're handed, but we can use a symmetry plane, and we can mesh one and then use reflection to put it in the other location. So this is automatically gone through and linked these parts together, so that as we mesh them, I only have to mesh one of them and I get the other parts for free. So it works in this case in kind of these handed structures, but it works generically across all kind of parts that come in as repeated parts. I'm just going to now, so let's take one of those assemblies. So I'm going to take this front rails assembly, and I'm going to use our link into batch mesher. So I'm going to go representations create, and I'm going to pick what type of mesh I want to create. So we have some out-of-the-box options. We also have the ability here to set up your own user representation using your own param and criteria file, which was shown in the 2D meshing, to define the mesh specs that you want. We're just going to use one of the out-of-the-box options. And so in the background here, it's launch batch mesher. So this session is still active. I can carry on working, but in the background, it's meshing my parts for me. And I'll just come over here and we can see what it's doing. So it's actually, even though I requested one set of mesh, it's actually split the job into two parts. So it's creating the NVH 5mm mesh representation that I asked for. It's also creating a common representation. And you can see it's working in parallel using, in this case, 7 CPUs, because it's using, my machine's got 8, so it's everything minus 1. The common representation is the mid-surface, and then from the mid-surface extracts the mesh. The reason we split it into two is so that if you want to generate another mesh representation, we use the same mid-surface. So if we get some results back and the mid-surface was a poor extraction, we can clean it up. We can save it, we can submit mesh, but we can submit future mesh as well. So we've got just two parts left working here. Excuse me. And while these finish up, we can come back over here. So this session, when batch mesher finishes, is going to provide us a little prompt, and we'll have the option to load in these parts. It's finished all of the parts now. It's just working on the post-run procedure. So I'll just give it a couple of seconds just to catch up. There we go. So it's finished, and it's going to ask me now, tell me what the mesh is finished. Would I like to load the mesh into the session? I'm going to say yes. And it's going to take the CAD representations out, and it's going to load in the mesh. So if I toggle back to the single view here, you can see these parts have the CAD representation. These parts have now this NVH 5mm representation. Kind of as I mentioned as well, if we look at the component here, it has assigned a property with the ID 1007, which is taken from this PDM property ID. So both the component and the property have the same ID. The thickness is 2.5 mil, extracted from the CAD during the batch mesh process. It has a material assigned with the ID and the name matching, again, the metadata. So it has kind of all of this additional creation with you, with it all the way just from kind of one-click representations create. The idea is that this gives you a really quick way to create your gel mesh, but we also actually offer tech mesh. You can do mid mesh through this process, and in future we're going to expand this to even more mesh types. I can take, so now we've meshed one side, we know that we have instances on this other side, so actually I'm going to kind of isolate these parts here, and I'm going to say, actually no, let's bring back this side. So we've got the two sides now, and I've got two different representations. This side's the mesh, this side's the CAD. So I want to propagate the mesh from this side to this side. I can do one of two things. I can either pick this side, and I can say representations load, and because these are instance parts, these have the same mesh representations that were generated over here on this side. So I can load in the MVH 5mm representation here, and so this again is going to toggle out of the CAD and load in the mesh. Because these are instances, and for simplicity all I'm going to do is delete a surface so we can see what's going on. I'm going to delete a surface, and I'm going to delete the associated elements. So I could take this part, and as we make design changes, you're not going to realistically delete a surface, but you might do mesh cleanup, because as this comes out of batch mesher, it's very good quality but maybe not perfect. But we can do instant sync, and then we can see that that change from one part is propagated to the other. So there's no need to do kind of a copy and paste and a position or a translate or anything like that. The part itself has a transformation information, so we know the offset from one part to all of the others. There's no one master part. You can edit any of these and propagate it to any of all of the others. And the last thing to show as well, so if we come back here, I created through batch mesher some very simple 2D mesh with our direct integration with batch mesher. What about all of these other parts that might have been meshed by the rest of the team? Well, let me go into the flat view and let me grab everything that's still a CAD rep. I'm going to use the power of the library to go representations load from library, and in the library I have mesh pre-saved because somebody has generated it, pushed it into the library, and I can now assimilate other people's work into my model and just load that in and build a model. So we can work in this really tightly integrated collaborative environment so that we can push and pull data across and build our model together. All of these parts, as I kind of alluded to at the start, have like a revision that came from CAD. Along the way, we've been populating library revisions, so you can see maybe here it's 7-3. So there's 3 revisions here, one for the CAD, one for the mid-surface, one for the mesh. I could take this part, let's say this guy here that we've cut a hole in. I can I can maybe representation save. I can add a comment, hole, no, surface removed, and I can save it into the library. That's incremented the revision, and for this part I can go in to library viewer, and library viewer holds the history of all of the holds the history of all of the parts that have been edited, and I don't know why library viewer is not coming up. This guy. Oh, okay. So within library viewer though, it should hold the history of everything that's done. I tell you what, I can show you it without using library viewer. So I'm going to increment the major revision. So this is now major revision 6, and I can through here. Well, actually, it's not going to show a lot because I saved it. Let me do something else. Hold on. Sorry. I take this guy. I isolate it, and I'm going to cut a surface here, and then I'm going to increment the major revision to 13. And so I've got a new major revision. It's not a very good example, but I can roll back and forwards between different major revisions. So for example, I can load, if I choose to load revision 12, I can load revision 12, which hasn't got the whole cut in. So each part we save into the library has a link to a certain revision. So as we get the next model build, we can say, okay, well the revision 12 has been meshed before, I'll just pull the mesh from the library and I'll reuse the mesh. Or I can see, that part hasn't been meshed before, I need to generate a new mesh for it. So when you're building future models, you can really reuse mesh that's been generated before, with that traceability back to which CAD version it came from. So there's that CAD traceability where the versioning is captured from CAD import and maintained through the solver deck all the way to the export. We can use Match to use our AI technology to link instances together to avoid meshing repeated parts. We use batch mesh integration to run parallelized meshing, giving us our best out-of-the-box mesh. We use instancing, whether it comes from the CAD import or whether it comes from the Match tool, to automatically sync mesh changes. And we use that library to enable collaboration so that we can use the different revisions and representations that have been built and saved into the library and really work in this collaborative environment. Thank you very much.